Organic chemistry. Just hearing that phrase, right? For a lot of us, it brings back these nightmares of trying to memorize just endless, super complex molecules. But what if I told you the secret isn't about memorization at all? What if it's actually about learning a language? I mean, just look around you. Right now, the device you're using, the clothes on your back, even the very air you're breathing out, it's all built on carbon. We're talking millions of known carbon compounds. Millions. So the big question is, how on earth does anyone keep track of all of them? Well, faced with what seems like total chaos, science did what science does best. It looked for a pattern. It looked for a logical system to make sense of it all.
And what it came up with was a language. Seriously, the whole secret to cracking organic chemistry is to stop thinking about it like a typical science class and start treating it like a language class. It's a language specifically designed to describe molecules with incredible precision. And today, you and we're going to learn the basics of its grammar.
Okay, so every language has a subject, right? Well, in the language of organic chemistry, that subject is always, always carbon. It is the absolute star of the show, the element that makes this whole thing work. So what's so special about carbon anyway? It really boils down to two key things. First, it's tetravalent. That just means it can form 4 really stable bonds at once. And second, it has this cool ability called catenation, which, is a fancy word, but it just means it's amazing at linking up with itself to form these long, super stable chains and rings. Put those two things together, and carbon is basically the ultimate molecular Lego brick. All right, class is in session. Grammar lesson part 1. Just like with any language, you got to start with your ABCs. For us, in organic chemistry, that means learning the prefixes. These little guys tell us exactly how many carbons are in the main backbone of a molecule. So take a look at this. This right here, this is basically the alphabet of our new language. If you've got 1 carbon, the prefix is meth. 2 carbons, it's F. 3 is prop, 4 is but. Now, after the first 4, it gets a lot easier. It's pretty much like geometry class, right? Pent for 5, hex for 6, you get the idea. It seems simple, but this little list is the foundation for naming literally millions of different compounds.
And here is a quick pro tip for you, coming from the famous teacher Ashu Sir. He once joked with his students, saying something like, "Whoever says sept for 7, I'll punch them." So yeah, remember, it's hepta, not septa. It's a pretty memorable way to make sure you get it right, huh?
Okay, so if the prefixes are kind of like our nouns, then the suffixes, those are the verbs. They describe the action, the bonds. If a name ends in "ane," it means all the carbons are connected by single bonds. We call that a saturated molecule. But if you see an "ene" ending, that tells you there's at least 1 double bond. And "ine" means there's a triple bond. Those last 2 are called unsaturated. The logic is super simple. For example, propane, that's 3 carbons, all single bonds. Propene, still 3 carbons, but now it's got a double bond in there. So we've got our basic words down. Now it's time to add some flavor, some adjectives. In chemistry, we call these functional groups. Think of them as little accessories that attach to the carbon chain and give the molecule its entire personality. And believe me, a tiny change can make a huge difference. You can take a simple ethane molecule, slap an O group on it, and boom, you've got ethanol. That's the alcohol in beer and wine. But swap that out for an oic acid group, and now you have ethanoic acid. You know what that is? Vinegar. See? These little add-ons completely change the game and define what the molecule actually does. Okay, time to put it all together. Let's combine all our new grammar rules. We've got our alphabet, which is the prefixes. We've got our verbs, the suffixes. And we have our adjectives, the functional groups. Now let's use them to build a full chemical name. It's really just like forming a sentence. And there's actually an official system for this, and it's beautifully logical. Here's how it works. Step 1, find the longest continuous chain of carbons. That gives you your main word. Step 2, spot any branches or functional groups hanging off the side. Those are your adjectives. Step 3 is super important. You number the main chain so that those add-ons get the lowest possible number, like a street address. And finally, you just assemble the name, piece by piece. It's a formula you can use every single time. And this is where our chemical language gets really cool. It becomes almost creative, like poetry. You can take the exact same set of building blocks, the same atoms, and just by arranging them in a different shape, you can create a totally new molecule with its own unique properties. There's a name for this, of course. It's called isomerism. Isomers are molecules that have the exact same chemical formula, the same number and types of atoms, but a completely different 3D structure. I love this analogy. They're basically like anagrams, but for chemistry.
Check this out. It's a perfect example. Both of these molecules have the exact same formula, C4H10. But look at butane on the left. It's just a simple, straight chain of 4 carbons. Now look at 2-methylpropane on the right. It's a 3-carbon chain with a little 1-carbon branch sticking off. Same exact parts, totally different shape. And because of that, they are completely different chemicals with their own distinct properties.
So here's the big takeaway, the most important point of all of this. Learning organic chemistry is not about brute force memorizing millions of different compounds. No way. It's about learning the rules of a language. Once you get the system down, the prefixes, the suffixes, the logic behind it all, you can start to decode and describe molecules you've never even laid eyes on before. And that really leaves us with a final kind of cool thought, doesn't it? If molecules are the letters and the words, then this language we've been talking about, well, it's the key to understanding the incredible stories the universe is writing all around us and inside of us. Everything from the very first spark of life to the next big medical breakthrough. So, the only question is, what story are we going to learn to read next?